Hello. So this is the first task of my machine learning internship at Systemtron, which is based on creating a car prediction model. So let us first look at our database. Uh, as you can see, we are using Picker database, in which we have name, company, year, price, kilometers driven, and fuel. And depending on these categorical features, we have to predict the price of the car. So let us move on to our code. Initially, we will just import all of our necessary libraries which we will need, and then also we have specified the style of our plot, uh, such as like ggplot. Now we will import our database, quicker car database, into the variable car. Then we will check its first of 5 rows, then shape of our database, general information, and you can see what columns you have in it, non-null count, and then dtype, which is basically data type. And before we move on, we will first take backup of our database into backup variable. So cleaning on the data, this line filters the data frame to include only rows where year column contains numerical values. Then it converts the year column to integers. This line removes the row where price column contains the string ask for price, and then converts the price column to integers after removing the commas. So basically what it does is, uh, let's say for example we have 45,000 in our data sheet, and we have written it as 45 comma triple zero. What it does is it removes that comma and replaces it with nothing, blank. uh, then we will move to the kilometers driven column. Here we basically split the kilometer and the value of the numerical value, and then we will only filter in the numerical value to our kilometers driven column of our new variable, which contains the database car. Then we will convert this numerical value into integer. Now moving on to the fuel type column. Here what it basically does is it removes out all of the null columns. And now we will again check the shape of our. Next, this line processes the name column to extract the first three words of each car's name, and then uh, it basically joins them with spaces. The data frame is then reset so that index starts from 0. In simple words, it just selects the first three words of the name column, in which we have our car name. Now we can check our clean data. As you can see, we have only selected the initial three words of our of any car, which originally was not the case, and it was much bigger strings, which we thought it was unnecessary. So then we will check our company column, year column, price column, and so on, and all of this seems all right. It seems cleaned, so we can successfully save it as cleaned car data .csv. And then we can check the general information of our new clean data, and to see just if we have successfully implemented proper data types for each column. Then we'll just create a statistical summary of all of the columns. Then we will also again exclude any prices which value is above 6 crore, uh, which can lead to outliers and basically be a hindrance in proper prediction. And now we will just check unique values of company, which as you can see in this array we have Hyundai, Mahindra, and so on. These are basically unique values. And now we will just plot a box plot here, where x-axis has company and y-axis has prices, and we can see how it changes with respect to it. And here basically, rotation 40 means we have rotated these names of companies in 40 degree and be horizontally aligned for better visibility. Moving on, we are again checking relationship of year with price. How prices of car differ uh, based on years. So we will create a subplot with 20 width and 10 height, where x-axis we are setting to year, y-axis to price, and then data we are taking from car. Again, we have done similarly what we did previously, rotating to 40-degree angle, just so it is very readable, and also horizontally aligned to right. So as you can see, the prices of car are in increasing upward trend as years go on, which is very expected. Now we will check the relationship of kilometers driven to the prices of the car, how it affects the price. Observing this relational plot, we can see the lower kilometer a car has driven, the more they are up for sale basically, except for this outlier it seems. Now we are going to check the relationship of fuel type with price, where we will create a box plot with x-axis as fuel type and y as price. We will take the data from the car database, and we can see how the price differs. We will now create another uh, relational plot, where we will put x-axis as company, y-axis as price, and then we will also color different fuel with different color through hue, and then depending on the size of this spot, we will identify what year it is, and then other parameters such as height and aspect. And then we will just again, this is x tick label. Basically it is more readable if I rotate it to 40-degree and it is horizontally aligned. So uh, you can see, for example, Hyundai seems to have more petrol vehicles, and Mahindra on the other hand seems to manufacture more of the diesel and LPG cars. Here you can see only one petrol car, it seems, at least one that is. And depending on the size of the spots, you can tell which year they were manufactured. Now let us extract the data for training. We will put these column names, such as name, company, year, kilometers driven, fuel type safely for training in X variable, because we have properly cleaned our data. Then price column for as our prediction target into Y variable. Let us first view whatever we have put in X variable, and as you can see we have columns like name, company, year, kilometers driven, fuel type, year. We will check the shape again to basically check if it is in proper format for applying training testing split. So we will import a train test split from sklearn model selection now, and then split our train test data into 80% training and 20% testing size. As you can see, we have set our testing size as 20%, so the rest will automatically be set to 80%. We will then import linear regression model from sklearn linear model uh, library, and import all of the rest of necessary libraries such as one hot encoder, make column transformer, make pipeline, and R2 score. One hot encoder is a pre-processing technique for encoding categorical values. Make column transformer and make pipeline are used to create uh, data processing pipeline, and R2 score basically is evaluation metric for a regression model. As you can see, we are going to use linear regression, so yeah, we will need R2 score for that. Moving on, we will be creating a one hot encoder object to contain all the possible categories. So uh, basically, one hot encoder object is created and filled with specific columns from the feature matrix X. This step is necessary to transform the categorical values into formats suitable for machine learning. We will be creating a column transformer to transform categorical columns. So as you can see, we will first make column transformer. We will apply this one hot encoder to these categories, which are name, company, and fuel type, and the remaining columns will be passed through. Basically, you won't be applying one hot encoding to them as they are numerical. We will store the linear regression model in LR variable and construct a pipeline. This pipeline includes column transformer and linear regression model. This allows for both data pre-processing and model training in one step. Moving ahead, the pipeline is fitted with training data such as like Xtrain and Ytrain. The model's predictions are obtained using the testing data, and we will be saving that in ypred variable. And now we will check our R2 score of our model, and we found it to be 76%. Even though it's decent, it's not really good. So we will have to find the optimal train test split through which we can get the maximum R2 score, which basically in turn makes our model more accurate. So we will run this code snippet, uh, which basically runs like thousand loops, uh, and evaluates the model performance with different random train test split. And for each iteration, new train test split is created, and the R2 score is calculated and stored in the scores list. To explain, you can see whatever we did previously we'll do here the same, but let's just take the test size as 10% instead of 20% as previously done, uh, and that is for to increase our training size a bit more, which is 90% right now. Then again we will load up our linear regression model, our pipeline with column transformer and linear regression, fit our training portion of our data set, and then again predict the uh, testing data, and then whatever score we get we will append it in this scores list. After that, through this np dot argument max scores, we will be able to find the maximum index of the maximum R2 score in scores list, indicating the best performance random split, which is 665. The value we got here is nothing but the index at which we got the highest score. If we want to find the actual score we got at this index, we can use scores in bracket np dot argument max and scores. So we got 92% score at the index 665. Now, before applying this new random state of train test split, let us first try predicting a new data point on the previously trained model, which we got score of 76%. And this will help us to compare both of the results. Basically, how well, if it was worth it to add this snippet or not. Thus, we will introduce a new data point with car name as Maruti Suzuki Swift, company name Maruti, uh, year of manufacturing 2019, kilometers driven 100, and fuel type as petrol. The previously trained model with accuracy at 76% gave us the price prediction at 4,707,000. Finally, the model is retrained on selected train test split with highest R2 score, which you can see we have taken NP dot argument max scores, uh, and the R2 score is here again calculated. And after retraining our model on this newly found random state, we get the score, new score as 92%. Now similarly as we did before, we will again import pickle and then save this new model as linear regression model dot pkl. Again, as done previously, let us put a new data point, or rather the same data point as we had put in our previous model, to just compare the results. So here we create a new data pandas data frame with columns, name, company, year, kilometers driven, fuel type with the new values in them as Maruti Suzuki Swift, Maruti 2019 year, 100 as kilometers driven, and fuel type petrol. And with pipe.predict, we got the predicted price value as 4,16,109. And when we compare this newly trained model's output with the previous one, there is a 16,000 difference, which is significant, though both are really well predicted. And moving ahead, this code snippet is actually not related to the rest of the code, but rather to extract information about the one hot encoding on the name feature. Pipe dot steps, uh, this basically access the steps or components of the pipeline created with make pipeline. In this case, the first step corresponding to the pre-processing step. This 0 and 1 value further drills down the transformer step within the pre-processing. Then dot transformer 0 1, which reaches the part of the transformer that is responsible for handling one hot encoding, specifically for name column, company column, and fuel type column. And then this categories 0 finally extracts the categories or unique values of the first zeroth, uh, wa- uh, uh, this index value. This is the first, what you can say, value of one hot encoded feature, which is name. In simple word, this code is accessing the unique car names, such as like brands and models, that have been one hot encoded as part of the data pre-processing in the machine learning pipeline, as we can see here. These unique names can be useful for mapping one hot encoded features back to its original value. Thank you.